Hello, I am Tommy Liu, and this is my submission for the online assessment portion of this job application. So let's just start off. I'm currently in PhysioLabXR, which is the software package that the PhD student I'm working under is creating and slash developing. And here is my first task. So in terms of like what I'm actually doing, I am maintaining slash developing the integration between my PhD software with PhysioLabXR with this device, wearable sensing's DSI-24. Now, currently, they do have a software program that does allow you to output the data from the DSI-24 to like the software program that they have. However, it's only a software program where you could just collect and view the data. There is no post-processing things that you can do that we can with PhysioLabXR, and this is the reason for our implementation of this device. So here's the initial, I guess, script. Some core aspects of the script is just grabbing understanding C API, C++ API. So their API for wearable sensing is based off of C++. So just trying to understand how to implement that within a Python environment itself was probably the most important aspect of this, just grabbing the data out of it, as well as adding some of the functions that they had with throughout the API. That was most important. And so after I finished this part of the project, we decided to make it a little bit more streamlined instead of and make it so that it was pretty much like a few clicks of buttons within the software just to get this device up and running. And so we have these three scripts here. The script is mostly just the initial script right here, but formatted in a way for these two to actually work. What we have here is like a little side window that will allow the users to choose different aspects of it. So whether or not they want to show the impedance of the electrodes or like the battery life of it. And currently they aren't implemented. We have been able to get the impedance out as well as the battery, but I'm still working on trying to output that into like a graphic that would be more user friendly for the people. And then this is just the interface between the two. And so we'll move on to I guess the more bulkier portion of my project, which is the NeuroCooked game. So the NeuroCooked game is based off of the game Overcooked, where the player has to choose different items to put on a plate to give to the user. For me, it's just going to be different items to give for an order. It's going to be using CVP, although based on my previous testings and current testings, I'm still trying to work on getting the CVP correlation values to be higher as they are quite low. Um, However, if that doesn't end up working, we'll probably just switch over to SSVP here. But here's most of the code. As you can see, there are a lot of comments and a lot of doc strings because I do find that keeping these scripts organized and the code organized, as well as just making sure that most of the code has something to go along with it so that I do understand it. If I say take a few days off and come back to it, I understand what's going on, as well as just other people looking at the code itself, because this is a public script and a public open source software, so other users can use this code and other codes to develop their own games or their own integrations. And I feel like that's important to have comments to explain every step of the way so that they could apply that to their own code. These large chunks of code are just me troubleshooting right now, trying different ways to get a higher correlation value for um, the CVEP. But yeah, this is just a Python portion of it that will go into um, the game. And of course, because this is just Python version, it's not technically the Unity part of the game. We do need a way to communicate between this code as well as Unity. And so this is where I feel like one of the most important parts of the code is. It's the RPC functions. The RPC functions are based off of gRPC, and it allows the script to communicate with Unity itself. And so, of course, the troubleshooting areas. But I have three RPC functions, which are the adding a sequence for the training. There's training the model as well as decoding the model. For this game, it will be a continuous decoding. So, and then we'll just use like the mode or like the most common decoded choice as like what the user used. And that's pretty much how it's going to work here. So I'll just move over to the Unity code here. And so we have the training script here. As I said, I do like to keep things neat and try to add as many as necessary comments as possible to try to make it super easy to understand. Although I feel like for this part below here, it's a little bit messy, and I will try to add more as I am still working on it. I guess one of the most important parts, I guess, about this part of the project would be like the update board function. So instead of having individual functions for updating individual portions of the screen that the user will see, I felt that instead of doing that, we just have numbers to represent what they are, and then just update it all in all with this update board function, so that it could just get like a refresh every time. It's similar to like refreshing a screen and stuff like that. So as you can see, when it comes to coding, because I kind of learned when I was, oh, actually, hold on, I completely forgot. There's also the documentation page for PhysiolabXR, because it is open source, and because we do want people developing their own scripts to develop their own experiments. We do have a documentation that does go out to a web page that I can show in a bit. But as you can see, there is a bunch of documentation, and I created two for the wearable sensing device, one for an attachment so that the wearable sensing DSi-24 can be used for the Vario XR2, which is a VR headset that includes eye tracking. It's well known for their eye tracking as well as their high fidelity visualizations. Apart from that, let's see, we got the wearable sensing DSi-24. This is an older version of it, like it is the one without the integrated script. So it is a little bit off, but it still works and still makes sense. But yeah, so I guess I'll just give a quick show of what the documents actually look like. So for at least my thing, the DSi compatibility with the 24, showing off how to attach it, as well as see, streaming data from the DSi-24. As you can see, I use GIFs here, but with the new update that I'm planning to do sometime next week or two, I will try to create like a more video thing, because I feel like more often than not, people would rather watch a video than just reading all of this stuff here. So here I have the docs. But as you can see, I do prioritize a lot of just understanding the code and making sure I have comments and like doc strings to ensure that when people read it or when I read it, I'll understand what each function does and what each part of the step does, each part of the code does with these comments. And also, I don't know if you guys noticed, but I do have a lot of modularization. I try to use functions as much as possible to simplify the logic as well as enhance the overall readability with my code itself. And yeah, I guess that's pretty much about it. I'll probably go into more about the difference between these two within the demo itself, and also just showing off the game. Even though it doesn't technically work, I'll be lowering the correlation value necessary just to show off that everything does work except for the correlation part of it. Alrighty.